half a year later, so 2008, late 2018, and then we started some, informal collaborations. We had some few projects here and there, and then I met the guys, the Hydra guys. They came to me to the university, I think in the summer of 2020, and they reached out to me, wanted to have some preliminary research in order to be able to talk to Block.Science later on. And this is what we did. So we talked for, I think, 3-4 months, did some, mapping out of the requirements, and then moved over to a more formal approach in line with what Jamsheed is describing, the Block.Science approach. And with Barlin together, we are working on the project for 7 months now, I think. Yeah.
About that, yeah.
Yeah, very cool. Nice. And just out of curiosity, are you guys involved in the Token Engineering Commons at all? Or I know you've got the partnership with the TE Academy too, but those are just two other communities that I've been working with or involved in. So
I don't have a direct connection with them. I think Block.Science is active, I think, in some capacity, but it hasn't crossed my my path individually. No.
Yeah. Cool.
I met, obviously, like I was involved in some events together with Jeff and with, no, I forgot his name, like the Commons, the stack guy. Griff. Yeah, Griff. Yeah, I met him quite a few years ago, and then we've been talking now here and there, but not really involved in a sense as you would maybe say that we are involved in the Commons, right? But we are touching base now and then. We are doing some exchange of materials, exchange of ideas sometimes, but it's more of an informal, friendly collaboration instead of a more targeted one.
Yeah, very cool. Nice. And so it sounds like you've been in the crypto space for a long time then.
Me, I started 2018, so this is exactly how I started. So before, at the moment I started my PhD, I started to start with crypto. So I got into crypto because I was working at a bank, and then for quite some time I didn't have much to do, and for 1 month I was reading and studying a lot about crypto, and then I immediately decided, okay, I understand it, I want to do it. So this is why I shifted towards the space. And luckily the institute opened up here in Vienna at the time, and it was the only place I could work, or I could engage with the community 2 years ago or 2 years ago while I was starting. And this is why I decided to enroll in the PhD, which got more serious over time. In the first months I wasn't really sure whether I want to pursue this academic track, but now I'm deeper and deeper into it, and try to streamline my work in accordance with that.
Yeah, very cool. As it goes, you always end up getting deeper and deeper. It's like, the whole thing's a giant.
Well, it's nice also because it's becoming more formalized. I know it sounds kind of counter to the idealism of sort of the the basis for cryptocurrencies as the decentralized movement to rule them all. But at the same time, you kind of want that formalization at the education level, at the pedagogical level, because otherwise it doesn't gain traction enough for people to take their their opportunity cost of what do I train myself in versus what could I train myself in. And I think that's really where this is really taken off. Is that we start to see a lot of people that are not necessarily senior in age, but have been looking at in the space of things like monetary policy before, or in institutional economics before, for example. And then they're making their transition over and saying, well, this is actually an interesting space, and let me build a program around it, so that people can come in, smart fellows like Kris and others can say, hey, I'd like to join this and build my own research agenda, my own footprint on this right from the beginning, right from that PhD level, and I think master's level. And I think that's really the key component here, is the penetration to people for whom this is now a space that has always been, in the sense when they're looking for a career, it has always been around, and to ensure that they have the training and the tools and the methodology available to be able to push forward.
Yeah, totally. A little bit of structure is definitely helpful for people considering to make the jump.
Yeah, I would go even a step further and say that the crypto space is, for me at least, the only space, or the first place I could get into, try to apply my knowledge that I learned theoretically. So during my studies, I had the feeling that I'm learning very theoretical content that I will never be able to apply anywhere. And this feeling got somehow, confirmed while I was working in the corporate sector for the first 5 years after my studies. But then coming back to this space and coming back to the place where we have these ambitious and smart people who really want to make it right is quite appealing to participate in and be able to use things that I wouldn't have ever imagined that I will ever get back to in my life.
Yeah, that's very cool.
And since the space is so new and so friendly, and so positive, it's a very good learning environment as well. So this is what I find very, very appealing to work in, because it's so positive. It's like very supportive in a sense. It's very nice. Yeah.
Ben has joined us. Hey, Ben, how are you?
Hi, Jamsheed. It's good to see you again.
Yeah, it's been a while.
Yeah.
Hope things are going
Kris.
well.
Yeah, it's going well, thanks.
Hi, Ben. Hi. We haven't really talked formally, but I've watched your
No,
educational.
not formally. Yeah.
Yeah, I've watched your educational series. It was amazing. It got me into cadCAD, obviously. So it was well done, the course, and pretty excited about the future steps that you're taking.
Awesome. Yeah, really glad to hear that. Got some exciting sort of new developments coming out soon.
Oh, great.
The voice behind all the modules.
Yeah.
Yeah. Had a fellow South African message me in from the UK to say how happy he was to hear another South African voice.
Yeah, that's very cool. Actually, Ben, I have a question for you. Jamsheed asked me what I thought the split of the cadCAD community looked like between North America time zones, Europe time zones, and Asia. I kind of guessed like 60-40. Would you have an idea? Or I guess 60-40 being America versus Europe. Yeah, would you have an idea?
Yeah, I guess my feeling was that the split would be more just because of the fact that there are two different time zone calls. So it'd be sort of like North American friendly versus, I suppose, Europe, Africa, Far East Asia, Pacific friendly.
No, Ben, are you there?
Oh, maybe he's dropped off.
Audio issues, possibly.
Yeah.
Well, we can follow up later. But it's a good question, though.
I'm just curious, just because, as you said, the uptake itself has it has a particular focal point or focal points that are U.S. based, and that's natural for the way it started up.
Yeah, totally.
And just to see at the same time, we've got these different other places that are our coordination point, Schelling points, like TE Academy and others that are based outside of the U.S., but nevertheless kind of act as feeders. So kind of understanding the strategy of just how much of that footprint the attention is being paid to in different directions is just something I was curious to know more about.
Yeah. It is really awesome, though, that like the discovery can literally happen from anywhere in the globe. And yeah, just kind of finding all of these organizations or communities through different channels. So there's no geographic limitations. But very cool. So we can, I suppose, get the call more formally kicked off. Just been kind of chatting a bit so far, but we usually like to start out with quick intros for everyone, and just kind of go around in a circle. I guess we're all kind of new to each other as well, so could be nice. We've covered a little bit so far, but Kris, would you want to start and just give kind of your own quick pitch, how you've gotten into the space and cadCAD, etc.?
Yeah, sure. Hi, my name is Kris Paruch. I am a researcher at the Vienna University of Economics at the Research Lab of Crypto Economics here. and I'm doing my PhD. So I started in the space roughly 3 years ago when I decided that I want to move from the corporate sector into the crypto economic sector and want to find methods how to build crypto economic systems. And after curating the space and after curating the content and meeting new exciting people, I found the token engineering community and I found people who are involved there and decided to share this path in my ambitions. And I started working on some token engineering projects, trying to to build models, trying to understand how systems work, and trying to see how these systems can be designed and improved over time. And with this, I started to collaborate with Block.Science and the cadCAD community, where we have some great people who are leading and building the space with respect to these frameworks and driving the development there. And this is how I got into system specification, into cadCAD modeling. And I'm currently working on this project, which is an evolution, a new evolution of an automated market maker, where I'm lucky enough to be able to contribute to the development of a new exciting market maker mechanism here.
Very cool. Cool. I can jump in next. So my name's Peter, actually, and I've gotten more officially into the token engineering space in the last 6 months, I'd say. Before that, I was actually working in the e-commerce industry for about 3 years, and before that, I was at university studying economics and math. Originally from the US, but actually moved out to Berlin about 1.5 years ago with my job, and then coincidentally got into token engineering and found out that a lot of it was kind of originating out of Berlin too, which has been really cool. Although not a lot of in-person events so far this past year, but yeah, excited to be here. And then regarding cadCAD, I don't have a background in development, but I was really hooked by the cadCAD EDU courses and just kind of the systems thinking and the modeling concepts and stuff. So I'm on the learning journey for Python development and learning how to apply cadCAD, but I'd say my expertise is in the token engineering world is more on the conceptual side of things and mapping out value flows and understanding that type of stuff. So yeah, involved a bit in the TE Academy, cadCAD with Common Stacks, a bit here and there. Kind of found my role as a coordinator, helping with research and things like that. So super excited to be here. Love learning about new projects and meeting the people behind them. So community calls are an awesome place for that. Really excited. Glad you guys could join us too.
Cool. I'll jump in. I'll apologize. My camera doesn't seem to want to work with Discord this morning, but my name is Jamsheed Shorish. I'm a senior research scientist at Block.Science. My background is coming out of mathematical economics and finance, and with an application to computational economics. My work has been mainly focused around model building, some of the ways in which we can structure different types of modeling of, let's say, frameworks in order to be able to derive properties that we would like to see preserved in the system as it evolves over time. So for that capacity at Block.Science, I'm sort of involved in a lot of the specification design that is later used as a blueprint, if you will, for the implementation within a computer environment, like the reference implementation, of course, being cadCAD. So I work closely with other individuals who are working on the development side for cadCAD and also for doing things like verification and validation testing, a little bit of which you'll see today. But my side is mainly on things like incentive design, mechanism design that goes into the specification that is later then taken for a reference implementation. So very happy to join first such call in the community, and looking forward to being able to assist Kris in any way that he needs for the presentation today.
Super cool. And Ben, if your mic's working,
yeah,
jump in? Cool.
Yes. Sorry, my internet connection just dropped out earlier.
No worries.
Yeah, so started with a background in engineering. I did mechatronics or control systems engineering, and then straight out of university, joined a number of startups doing sort of development across the stack, from doing DevOps work to mobile application development, all sorts. And then eventually joined Linum Labs, where I started getting into the sort of cryptocurrency and blockchain space, and was quite glad to come across Block.Science work on cadCAD when they opened it up for the beta. So I started using it as a beta tester, and sort of a year or two later managed to do a couple of freelance gigs doing cadCAD sort of modeling and simulation work, and then joined Jonathan to build up cadCAD EDU. Always had quite a sort of passion for education, and I think it's a great skill to have, to be able to teach people about complex topics, and that's where I am today.
Very cool. Awesome. So we could jump right into the presentation then. Kris, if you want to share your screen or...
Sure. With this in mind, let me share my screen. Am I able to share my screen and show my video, or should I rather just...
That should be fine.
Okay, so I am going live now, and you should be able to see my screen now. Is this correct?
Yes, got it.
And now you should be able to see the full page presentation. Is this correct?
All set.
Cool. Okay, so let me get started on what we're going to talk about today. We want to talk about the Hydra AMM verification, which is to be decomposed in 3 words here: Hydra, AMM, and verification. So Hydra is a project that is building an AMM, which is a market maker, an automated market maker, and token exchange mechanism, if you want. And verification means in this context that we are building a framework that would allow us to compare this new design of a market maker to an established design of a Uniswap. And in the presentation today, we want to talk about how to verify this framework. So what is it all about? Hydra Pool is an innovative AMM design. So there is an innovative idea on how to improve or how to change the functioning of a market maker, in the sense that there are several changes to be made. And you can make, if you want to iterate on a market maker, on the concept of a token exchange mechanism, you can think of changing several things. So you can think of changing the structure of the pool. You can think of changing some parameter values. You can think of changing, for example, the fee mechanisms, and so on. But in this context, the Hydra team thought of changing the pool structure and everything that goes along with it. What do we mean by that? In a Uniswap pool, you would pool 2 assets together, 1 asset on the left-hand side and 1 asset on the right-hand side. And the Hydra AMM team wants to pool all assets on one side. So the goal is not to have an instance where you would have 2 assets. The goal is to have an instance where you have a distinct number of assets that you wish. And all the risk assets would be on the left-hand side of the pool. And on the right-hand side, you would have a base asset that is not provided by the liquidity provider, as in typical AMMs usually, but it is minted by the protocol. So it would go like this. If a liquidity provider wants to bring assets to the pool, he can do so providing assets on the left-hand side. And then the protocol accordingly would mint the token, the base token on the right-hand side that would represent 50% of the total value. So this is actually a restriction that the team wants to establish. And the goal of the Hydra team, and this is what they came to us with, was to develop a cadCAD model that would validate the pool design and their specific mechanisms. So they wanted to specify and wanted to find the optimal mechanisms that would support their cause in the context of an exchange mechanism. And the second task for this model would be to be able to compare the performance of the system to Uniswap. So let's talk about an AMM briefly, so that we are all on the same page. An AMM is a system that obeys to prescribed invariances derived from business requirements which dictate how the mechanisms work. So usually you could think of something like a constant product market maker that would be an invariance that would be derived from business requirements I mean, they're maybe a little bit tricky to argue here. Why would you choose particularly a constant product? But it makes sense because one of the reasons why you could do so is that you wouldn't drain the pool totally, because the last unit of a token in one pool would become extremely expensive if you were to drain it totally. So this could be a reason as a business requirement to say, okay, I want to have this invariance in my pool. And then the AMM is a market maker that obeys to this invariance. And all the mechanisms that work in this environment support this cause. And the typical mechanisms that we have are the add and remove liquidity mechanisms. So you would have someone who would provide or remove liquidity from the pool. And by this action, the goal is, a business requirement, is not to change the prices of the tokens relative to each other in the pool. So you have to find a mechanism that would allow this by not changing prices. And the second and the final mechanism in an AMM that is typically involved is the swap mechanism, because this is what the AMM is kind of for. It allows other users, not the liquidity providers, but the traders, it allowed to send in tokens to one side of the pool and retrieve tokens from the other side of the pool. And the goal of the Hydra team was to use the same set of mechanisms, so to allow adding and removing liquidity and to allow swapping tokens, but with specific functionalities in accordance with their needs. So let us talk briefly about the structure of different AMMs. I mentioned this briefly in the beginning. So one thing that you could do if you were to innovate on a market maker, you could think of the pool structure and try to improve it or change it. And we can see here that in Uniswap, you would usually have two assets that are pooled together in one pool, and you have one function that is the invariance, that dictates the invariance between the token amounts in both pools. So this is the Uniswap case. You have only two pools, and they are connected. So what you can see here is that if you want to have an Ethereum and Bitcoin pool, and you want to exchange Ethereum for DAI, for example, you would have to allocate the capital to the different pools accordingly. So it's kind of capital ineffective, which was one reason why the Hydra team decided to pool all of the assets together. An extension of this concept is the balancer, which allows you to pool more than two assets together, and the balancer allows, I think, up to 8 or 16 assets into one pool. And there are pre-described weights that are being defined in addition to this, where you could say that all values of all token would always have to keep this value of the total value of the pool. And then come some iterations, and I want to describe briefly Banker and Hydra. So Banker iterates on the concept of Uniswap, where it says, okay, it's okay to provide the left-hand side of the pool, but we will mint the right-hand side accordingly. So it is like an elastic supply of the right-hand side. And Hydra innovates on this concept again by extending the logic to not having separate pools, but having one pool altogether. So this is the key idea of the Hydra AMM. That you would have on the one hand side all the risk assets, and on the right hand side a dynamically minted base token. And this is actually how the mechanisms then should work. So you would have the Hydra mechanism that would be providing liquidity in asset 2, would mean that you provide as a liquidity provider the asset 2, you get the HDX token is being minted by the protocol, and you receive a share of the token 2 as a liquidity provider. If you were to swap tokens, you would provide the asset 2, for example, you would retrieve asset 3 from the pool, and there has to be some form of a rebalancing logic that would allow fair token exchanges to happen. So one concept that is associated with this mechanism is that if you swap tokens, you would change prices, and therefore you would maybe have some liquidity providers to be worse off since you've swapped tokens. And in order to forgo this problem, there is some reallocation mechanism involved to have the new the notion of fairness in the protocol. So the goal of the presentation that we're having today is to explain how the structure of the cadCAD framework was designed to be able to compare the new Hydra AMM to a Uniswap AMM. And we can talk about the Uniswap model and the Hydra model that were linked together in order to build this framework. And we can show you the Uniswap model because it is open source. The Hydra model is not open source yet, but we can talk briefly about some of the verification results that we can present today. And in line with this, we can also talk about how the model structure was verified. So once this framework was built, once the team decided on this is how we want to set up the modeling framework, then the team proceeded with the verification, which was basically showing that both sides of the model do the same things. So if you have the same starting conditions on both sides, if you fill the Uniswap instance and the Hydra instance with the same starting conditions, with the same initializations, and you have the same agent actions and each time steps, which are predefined action sequences. So there's no behavior, but a predefined, just, I'm doing a liquidity provision, agent 2 is doing a swap, and so on. And if we have the different resolutions and mechanisms that are associated with the models on both sides, we still receive the same qualitative results. So this was the verification structure, starting with the same conditions, letting the agents do the same things and on both sides, and applying the different resolutions, applying the different mechanisms that are native to the protocols, and then still observing that we have qualitative results which are comparable. So let us talk first about the framework. So how to compare, how to even make possible the comparison of Hydra and Uniswap. Remember, Uniswap is a modeling is a protocol, but also the model associated with Uniswap allows you only to pool two assets together. So there are two assets that are tied together via this invariance equation, via this invariant property of the system that we described briefly before. For example, this can be a constant product or a constant sum or whatever you wish in a constant function market maker. And what is important to remember is that there are multiple pools of two assets each. As we said briefly before, there is not one single pool, but there are up to, I think, 30,000 of pools already for different tokens to be exchanged with each other. In the Hydra context, there are n assets, so a number of assets that are tied together, and there is only one pool for multiple assets. So this is the logical change, right? Instead of multiple pools for two assets, there is one pool for multiple assets. And in order to build this comparison, so in order to allow comparing the new Hydra idea to the existing Uniswap framework, it was necessary to copy several instances of the Uniswap model. And the minimum viable framework consists of 3 instances. So you can see that you would have 2 risk assets, I and J. And you would have to build 3 instances. The IQ instance, Q in this case, is the base token that is associated with the Hydra pool. So you would have the IQ instance, the JQ instance, and the IJ instance. And this would be a 3-fold copy of one Uniswap model, constituting the Uniswap universe. So this would be the left-hand side of the modeling framework. And on the right-hand side, you would have the Hydra model. And the difference is, as you can think of probably, is that since the Uniswap model only allows 2 assets to be pooled, so in order to replicate all of the things that can happen in the Hydra universe, you need to construct this framework of 3 instances. And the IQ instance is used for liquidity provision in risk asset I, and for I for Q and for Q for I swaps. So whenever you would go to the Hydra pool and you would say, I'm providing liquidity in risk asset I on the left-hand side of the framework, this would be replicated in the IQ instance. If you go to the Hydra pool and say, I am swapping asset I for J, this would happen in the IJ instance of the Uniswap framework, and so on. And this is shown here. So this is actually the whole framework that we've designed, taking 3 copies of the Uniswap instance of the Uniswap model, IQ, JQ, IJ, and comparing it to the Hydra universe, where we would have one Hydra instance that consists of slightly different variables, right? So as you can see here, you have the base token, the risk token, and the shares of this pool. Here you have again the base token, the risk token, and the shares of this pool. Here you have both risk tokens and the shares of this pool. And in the Hydra universe, you would have the pool variable, which just pools all of the risk assets together. So this is again the left-hand side, as we described before, the left-hand side of the pool consisting of all assets. And on the right-hand side, you would have the base token, you would have the total amount of Hydra in the system. So this is the variable H, and you have the shares of this instance. So this is actually it. So this is how the framework was designed, and this allowed us to replicate whatever can happen in the Hydra world if you would pool all of the assets together. In order to replicate this in the Uniswap sense, you would have to copy at least 3 instances and replicate the behavior there. Okay, so let's now talk about the verification, so the second part. And what we did is we defined a test case. So here I listed 2 actions. So in the verification test, we said, okay, we will let agent 1 do this and agent 2 do this. So we have composite action tests. And we initialized the agents on both the same, actually. So it was like the same definitions of actions, the same starting conditions. And then we guided them through the Uniswap world and the Hydra world and saw how the comparison results look like qualitatively. So this approach allowed us to see how actions and events will manifest in both universes.
Maybe just to interject, we're not actually introducing agent behavior here. We're simply specifying one action for each agent. The agents themselves then are typed according to the behavior, according to the actions that they are taking, not according to different behaviors.
Thank you. Yeah, true. Okay, and then before I move over to showing you some example notebooks, I wanted to give you a note that we are talking about that we are starting a course on omnipool engineering and simulations, which would be precisely dealing with how to design the Hydra AMM and the liquidity subsystem, the whole process of engineering the system design, the theory behind it, the general dynamical systems, the mathematical specification, the method that we use, the parameter selection under uncertainty, and where we invite you to participate and choose your own research question, team up with us, and show how you would use the cadCAD model and learn how you would use the cadCAD model in order to answer specific research questions. And applications are open until the 11th of July, and you can use this link here in order to get there. We are very happy to get your applications. Okay, so let us move over to some notebooks. First of all, I want to show briefly, because this is open knowledge, so I want to show briefly that there is on GitHub in the cadCAD demos organization, there is a Uniswap model that you can use and you can play around with. It is open source. And this model is actually what we started with. So what was started with in order to build the framework on the left-hand side, right? So remember, we had 3 instances and we copied 3 of these instances. We amended them accordingly to do what we want the model to do. But we started with this open source model and built then the Uniswap world out of it. So you can go here, you can see that you can check out the files if you're interested, and you can see how it works. So you would have the partial state update block, which is very straightforward, where we would have the user actions that are again predefined, and we have the variables that are updated, the balances of each side of the pool, and also the token shares. Here you have the state variables, the system parameters, and in the utils you see that here we have the specific functions that are being called whenever there is an action taken by an agent. So you can check out this model if you wish. But what we did with it is we extended it in order to be able to replicate what we wanted it to do. So you could see here, and I took a snapshot of the partial state update block for the Uniswap side, because remember, the Hydra model is not open source yet, so I cannot show you the code here, but I wanted to show you here that we changed the partial state update block that you have here, and it would obviously include more variables, and you see that it includes the RI, QI, and SI variables that are responsible for the IQ instance of the Uniswap. Then you have the J instance, and you also have the IJ instance responsible for trading between two tokens. So this would be the variables that are associated in the partial state update block with the Uniswap world. And you would see that we also have some metrics that would be the prices that we're looking at, prices between the tokens. And in order to make sure, so this is also a snapshot, in order to make sure that we are starting with the same conditions or doing the same actions on both sides of the universes, we have some extension here that secures that we have states that are giving us the choice, the size, and the direction of the actions that are being then guided through the system. Yeah, so this would be everything I wanted to show you about the model that we started with. And remember, we copied this model 3 times. We built the 3 instances, and then we started the verification tests. So I can go directly to the demos. I prepared 4 demos for today. We can talk about them, each of them if you want. So let me start with a simple, let me start with liquidity demo that would show what's going on. And here you see that we have the data frame that allows us to see what happens on the Uniswap side and what happens on the Hydra side. We have everything that is associated with it, with the results of the simulation. And then we would go through all of the instances in our notebook. So you see, we start with the IQ instance. That in this test case where we have an event that we prescribed, which is a liquidity event. So you see that we have the liquidity going up in the IQ instance because there is some agent providing liquidity to the pool. And since he's providing liquidity in the Uniswap context, he also has to provide it for both assets. So he has to provide the base token, but he also has to provide the risk asset. So both of the quantities of the token go up accordingly. And the agent receives the shares for the liquidity provision. So this is what you can see here, obviously happening on the left-hand side on the Uniswap IQ instance. And you see that the price of this asset is going down over time. For the JQ instance, which is the next instance that we're looking at on the Uniswap universe, in this test, we see that there is some agent who is swapping. So not only the agent 1 or one of the agents is providing liquidity in I, there is another agent who is swapping the base asset out of the pool for the J asset into the pool. And this is why you see that the quantities of both tokens move down or up accordingly. So you see that the base token is being retrieved from the pool and the risk asset J is being injected into the pool. And since this is a swap, you don't see anything happening to the J shares, which is what the system should do. You also see the prices, the price movement here. And in this test, we don't have a token between two risk assets, so there is no change. There's nothing happening in the IJ instance. So you see that here everything is straight. And then this is being compared to the Hydra side. So now we're moving over to the Hydra universe where we say, okay, how would this look in the Hydra pool? So do we have the same results? And you see actually that the Q, so the base token in the omnipool, the right-hand side of the omnipool, is being increased, and the total amount of age in the system is being increased, and the shares of the omnipool in Q are being increased as well, because one of the agents is providing liquidity, so therefore the Q has to increase. The risk side, for the risk side, you see that you have also the risk asset I is being provided to the pool. So therefore, we have this pattern here emerging. For the Jade asset, so the other risk asset, which is, remember, being swapped into the pool for the base asset. So this is what the other agent is doing. You see that this is also happening as we would expect it to happen for the Hydra side of the pool. And there is an additional cadCAD asset which we introduced in order to see if there will be changes or if there will be any effects on untouched or unaffected assets in the end. And the nice answer here is that there are no changes to this pool.
And just to interject that the transmission channel for which that would have affected the asset K is through the price, because the price itself, these prices are in terms of the base asset. And so changes that would occur in the base asset, if we weren't actually validating correctly, could propagate to the change in the price of an asset that isn't involved in any of these exchanges, and that's one of the reasons why we wanted to ensure that that wasn't the case.
Thank you. Nice. And then we have some plots that show price changes in the Omnipool as well. And I think that this is everything that, relative asset prices and so on. And this is what we would see on the global state level. And then we also can look at the agent states, because we would have 8 agents implemented into the model. And we wanted to do it like this because we wanted to have, for each action that we decide that is going to happen in the model, to have one different agent to act in order to be able to track what's going on. And therefore, there are also local states and local agent states that we can track and see. And we see that what's happening on the Hydra side and on the Uniswap side for the agents. But this is obviously not so beautiful as if we were to plot it. So you see that here we have the agent 1 who is providing liquidity in this context, and he is swapping out the asset, the J asset. This is the agent who is. This is actually the agent who was responsible for the JQ action. And you see that here there is a second agent. This is the agent who was responsible for the liquidity action. So this is one who is providing liquidity to the pool. And this is what you can observe on the local agent state. And other agents do not act because we only choose 2 actions, and this is also mirrored in the model by taking 2 models. And you could see the token holding. So this would be if we just count the tokens that they hold, and here we would have the agent values if we multiply it with the prices. So we want to see how the values will transform over time if we perform these actions. And these things happen on the Hydra side, but as well. So you see that here the agents on the Hydra side, as we said, are doing the same things. And this is just for confirmation that the same agent states are amended accordingly. Yeah, so this would be one example notebook that we talked through in order to verify that the actions that we prescribed, and we initialize the agents and let them do particular actions, that we observe that the system states in the Hydra universe and in the Uniswap universe are happening accordingly. So there would be a second notebook that we can look at. This is a swap notebook, which is basically doing the same thing but with different actions. So if you see here, for example, we have in the IQ universe, in the Uniswap universe, in the IQ instance, you would see that there is an agent who is withdrawing the base asset and providing the risk asset here. And you would see that there is also an agent who is withdrawing the Q asset and providing the J asset. So there are 2 agents who are taking the base token out of the pool and providing some risk asset, one the I asset and one time the J asset. And again, there are no swaps between tokens. So in particular, this naming convention is maybe not the best one here, but this is what happens. And if you look at the Omni side of the pool, you see that the same things are happening as expected. So there would be the same replication of the same patterns, verifying that the model works as intended. But I don't think that this is very exciting to talk through here, because what we can extend on now would be to look into a parameter sweep notebook that we built in order to see a different test case. And we've done this in order to test the mechanism. So in our derivations, or for the Hydra universe, there were some mechanisms that are dependent on parameters, which means that we have to choose particular parameter values in order to optimize for particular metrics. And in order to do so, we performed Monte Carlo experiments. And these Monte Carlo experiments would allow us to see how the situation will evolve if we repeat the same experiment several times, drawing from the same distribution, but taking for the mechanisms different parameters. And there was this parameter A that we chose to sweep over that could have the value of 1.5, 0.5, or 1. And in these series of experiments, we just tested how the system will perform when we have different parameter values. And the test case in this notebook, I don't know, Jamsheed, can you help me out with the test case that we have here? Do you know it by heart?
It looks like it is the add liquidity event followed by swaps would be my guess. So we have one add liquidity event around period 10, one remove liquidity event at period 90, and then in between we have swaps between assets I and J. That's my memory of this. And then the randomization that's happening in the Monte Carlo, I believe, is the initialization of the reserve values in the pool. So we have different amounts of initial reserves that are in the pool for each of these, and then these are randomized, and so we're drawing from a distribution to see whether there is sensitivity of the results, both upon the distribution of the pool reserves, but also upon this parameter. So for each of those parameters, there's a Monte Carlo run, a series of Monte Carlo runs, and then we compare both across the parameters and within the space. And so for a single snapshot, for example, here, for the scenario where this parameter A equals 1, we see all of the different Monte Carlo realizations plotted, which give us a band of realizations. So the different initial conditions give us different trajectories, but we're seeing all of the trajectories overlapped upon each other to see whether or not there's a general trend or whether there's no trend at all. In this case, for example, you can see that the reserve goes down as a trend, even though the individual trajectories, which aren't displayed, of course, have variation from period to period based upon that initial condition difference. And then we see that the weight of the asset within the pool, which is a derived quantity, is steadily increasing at the same time. And we also notice that the share itself remains equal to 0 throughout all of the simulations. So that's actually all of the Monte Carlo runs in the yellow are superimposed over each other, because that's a restriction that is a system restriction that is being obeyed in every Monte Carlo run.
Thank you. Yeah, this is cool. I actually prepared another notebook in order to introduce the Monte Carlo runs, but I started with this parameter sweep one. Okay. Before. So yeah, this would be the parameter sweep notebook that allows us to see these things, and we have different plots here which show the same things in a different way. But I'm trying to find one that is very nice. Here, for example, you would see that here you see the different starting conditions, right? So you see that you have different initializations of the starting value of the pool. So we would start with something around 100,000, but we would draw from a log normal distribution, and for each of the Monte Carlo runs, we would randomly set the initial value of the pool. And the goal of this test was to show that regardless of this instability here, we have stable behavior throughout the system.
And that's a statistical. If you want to go back up, that's a statistical representation. What's happening here is we're getting a band of the maximum and minimum of each trajectory at each period across all Monte Carlo runs, and then that middle line is the mean, I believe, mean or median. I think it's the mean of all of the values for each of the time steps for across the Monte Carlo runs. So there isn't any one Monte Carlo run in particular that actually has that dotted line behavior. This is just how it was as a trend on average for each of the variables that are being presented.
Correct.
Very cool. And is the parameter, the initial parameter is the value of the pool it's the initial value of the pool. That's what's changing.
So you have the parameter sweep between the different values of A, and A is a parameter that is associated with the mechanism itself. But what is changing in this Monte Carlo run is the different initialization of the starting balances of the risk assets in the pool. Mm-hmm. But let me get into this notebook that was actually prepared, to show precisely the things that you are asking. So we constructed two blocks of experiments, block 1 and block 2, and block 1 was designed to randomize the initial balances in the pools, and block 2 was designed to randomize the trading sizes for the agents. And you see here that you have the balances for the I pool and the balances for the J pool, which are drawn according to this mean and to this sigma mu ratio. So in this set of experiments here, so you have the set number one, you have 100 different Monte Carlos runs. For the parameter choice of 0.5, you would say I'm starting with this mean, and I'm drawing according to this distribution that has the sigma, which is 50,000 in my case. So this would mean that my starting conditions are looking like this, right? So this would be my starting conditions for each Monte Carlo run. For the balances in the I pool. And for the J pool, you would have this as well here. And this is what we randomized in this block 1 experiments. And you would see that we would still perform the same actions. And in this case, we have the provide liquidity event at time step 10 and the remove liquidity event at time step 90. And in between, we have, I think, a random action of trades going on. And you would see this happen. You would see the random trades here, and this would allow you to compare the Uniswap side and the Hydra side. But since you see that you have this Uniswap pool that is initialized randomly, you would have this very broad band of starting conditions here that you start with here, right? So this is actually the thing that you randomize over.
Quick one. How did you guys pick the time step points when the liquidity providing events would happen?
Just random. So we decided that we want to have this trading sequence. We want to have this action sequence where one agent would provide liquidity in the beginning and then remove it near to the end, and the other agent would do random swaps in between. So he would start at time step 0 and then do it throughout the simulation. And we picked this with the idea in mind that we want to have something that would allow us to assess impermanent loss. And we wanted to simulate a situation where there would be one agent who is providing and withdrawing liquidity, and there is someone else trading, and we wanted to be able to derive a metric and also to be able to encode these calculations in the model such that we will be able to see whether this agent who provided liquidity experiences some form of impermanent loss. Mm-hmm. So this was the idea behind this action sequence that we decided to impose here.
And just to clarify, these last two notebooks are really less about verification and more about actual efficiency testing, where we're looking at, now that we have in the previous first two notebooks that we verified that the Uniswap side and the Hydra side are doing the same thing for the same initial conditions. Once we run the same types of experiments, for example, this add, remove liquidity plus trading in between, we can assess the efficiency of things like slippage and impermanent loss between the two environments. So not just to get numbers within the Hydra pool, but also to be able to say, because we verified it before, that the Uniswap side is performing the same types of activities, and then we can perform measurements or metrics upon the output of what's happening in each case, and then compare them side by side and say whether one is having a larger amount of impermanent loss given a particular time period for the add remove liquidities, or whether there's a slippage difference between them and so on.
Got it. Very cool.
Yeah. So with this in mind, I think that this was everything that I wanted to show you today, but I'm very happy to stay here for a Q&A session if you're interested in some more detail, or if you want to have some more explanations about particular things that we did. As Jamsheed said, I mean, the first step was only verification, then some KPI assessment, and then the road forward is then to extend the model that we've built in order to build more sophisticated agent behavior or strategies or whatever you can do based on the understanding that the model is verified, that it's working as intended, and it produces the results that it should. Now we can start injecting more sophisticated behaviors into it.
Yeah, very cool. This was incredible. Very well explained too. Everything. Really appreciate the visuals and all the notebook demos you set up. One question that I have is, at what level do you guys observe KPIs? Is that at the agent level or higher than that?
We do that at both. So we do assess pool level metrics for things like pool impermanent loss, for example, but also the individual. What does the individual suffer if there's a particular agent that adds and removes liquidity? What is their personal P&L essentially? What is it that they would have achieved had they held the asset outside of the pool versus what has actually occurred and transpired when they removed the liquidity from the pool? So these metrics are applied both at the global level, but also at the agent level for those actions that are.
Got it. Cool. And how do you guys think about the effects of external systems to Hydra on how Hydra would perform, like other DeFi protocols and liquidity providing opportunities and AMMs across the ecosystem? How do you guys account for that in a model like this, or is that kind of coming down the road?
I think the first step here was just to facilitate the comparison between the Uniswap and Hydra. A model or logic in order to be able to develop the Hydra system, right? So the research question driven by the project team was to assess how well would this system perform in comparison to Uniswap. But down the road, as you say, is definitely a comparison across the market, right? So being able to assess the metrics in comparison to what you can observe in other AMMs. But since Uniswap is the most prominent one, and it is something that there was this off-the-shelf model that we could use in order to build these instances, it was very straightforward to take this decision to design it like this. But maybe Jamsheed has to add more to it. But this was the starting point of the first comparison, which definitely has some space for future extensions as well.
Yeah, the nice thing about being able to set this up is that you can, as you had mentioned in your question, extend the idea of what the behaviors are in response to external factors. I mean, that's one of the great things about cadCAD's extensibility is that once you have coded up an idea about how individuals are going to behave when they compare the benefits that they get from one particular investment versus the benefits that they get from another, that kind of opportunity cost metric that can be measured can be encoded as a kind of behavior. For example, a speculative type of behavior individual or a noise trader behavior of an individual. These things can be set up. And I think indeed one of the larger overarching goals of coming out from the Hydra team is that they would like to be able to set up a whole set of standardized test suites which actually encode behaviors that can be plugged in more or less or swapped into and out of the cadCAD framework. And you say under this particular behavioral regime, when an oracle says the price is actually, the price of Ethereum has tanked externally, what are the things that are going to happen within the Hydra pool? What are the things that would happen within the Uniswap pool? And then we can compare those two. So it's a nice way in which the power of the extensibility of a reference implementation like cadCAD can be married to the idea of building particular types of scenarios based upon behavior that then allows these external factors to be brought in, not necessarily directly into the protocol or into the mechanism, which may not depend upon the oracle at all, for example, an external price, but rather through the lens of what it is that the individuals themselves, conditioning on what they see outside, will actually perform within the model. And having such a standardized test suite, although it doesn't exist yet, I think is a very nice future project moving forward that could be implemented either within the Hydra ecosystem or certainly for use generally when you build such AMM representations to the community at large. So that's hats off to the Hydra group for thinking about and discussing this. This is something we're still kind of considering. And I also should mention parenthetically to that type of a development, just a quick shout out to Matt Barlin, who actually was the one who coded up these the initial comparisons between the triple instance Uniswap world and the Hydra world. Want to make sure that although he can't make it because of course he's in the U.S. time zone and is hopefully still asleep, that he gets the credit and the kudos for putting this together. So
yeah, no, this is incredible, awesome. And what are some of the next opportunity areas that you see for the model? I know you guys have the research track coming up with the TE Academy. Is there a particular question that you would like to see you have yourselves maybe, or that you might expect the group to work on next?
It kind of depends on what the group decides to come up with for their own research idea. But I think that one of the driving ideas that we would like to suggest to the group would be something that would incorporate a fee mechanism, because the model as we have it currently doesn't really include any extensive fee logics that would be able to shift to move the behaviors of the mechanisms accordingly. And one idea of the research track that is upcoming is to find the suitable fee framework that would be able to reach system goals or support system goals that the project team envisages.
Yeah, very cool. Awesome. Well, that's the top of the hour also. Anything else that we'd like to add? I'd just, again, say thank you. I learned a ton. So, yeah, anything else?
Yeah, just wanted to say thanks very much to both of you for presenting this. I think it's always really exciting to see people's implementations of simulation techniques, and especially the visualization afterwards as well.
I'm glad you liked it.
Yeah, very much so. It was a pleasure to be here. So thanks for the invitation from both of you. So thank you.
Yeah, of course. And I will share the content, the recording, and some notes that I have with you guys after too. And yeah, that sounds great. All set then. Yeah, we'll wrap up this July community call then, and hopefully see you all at the next one if you're available.
Great. Oh, I should just mention that I did post inside the in the text channel the link to the Token Engineering Academy for those of you who are still interested in applying. That is there. Remember, the deadline is Sunday, the 11th of July.
Very cool. Yeah, and I can add that. Oh, looks like my computer might have froze. Okay, we're back. Sorry, computer froze. Yeah, I'll be sure to add that note in our follow-up material too.
Cool.
Very cool. All right.
Excellent.
Yeah, have a great rest of the week, everyone.
All right, thanks.
Bye.
Same to you. Thank
See
you.
you around.
Bye.
Thank you.